Design automation can be used with files from many locations, including BIM 360. When we connect the two, we have all the power of automation directly inside our BIM 360 account. My name is Augusto Gonçalves. I'm a Forge advocate at Autodesk since 2008. I've been working with Forge technologies and desktop technologies like AutoCAD and Revit. Today we are going to talk how to connect design automation and all the four engines with BIM 360. We're going to show you a few samples and how we can get data from BIM 360 and push data back to BIM 360 and also to different sources in case we want to store additional information. Let's see it in action in a few sample scenarios. The first one will be about additional properties, then how to perform auto update on our models, and last how to do design check or a basic design check on our models. This first sample is using design automation for Civil 3D, but we also have a sample using design automation for Revit. On this sample, as soon as we open a file from BIM 360 on our viewer, we use design automation to extract the additional information we want, and with that additional information, when that additional information is ready, we show that on the property panel. So how does it work? We select a file version from BIM 360 using the Data Management API and send that to Design Automation. Inside Design Automation, our code, in this case or on those two samples, a .NET code, will extract the properties we want, indexing those properties using the external ID of those elements. For an AutoCAD drawing, the external ID is the handle. For Revit, is the unique ID. With the additional information, we save that as a file, a JSON for instance, and store that on a separate location like OSS. With that information, then when we open the viewer, we customize the property panel to show that additional information for us. Let's see the source code for this sample. It's available on GitHub, and you can try that on Civil 3D properties, or it's also available at the custom properties for Revit. They both use the same approach, and you can see here the live small animation showing how it works. In the case of the Revit sample, we're extracting the compound structure information layer information from walls, so we can calculate the actual cost of those walls later. So when I click on a wall, I can see that I have additional properties with the width of each of the layers on my wall. To run this sample, you need your Forge account, but you also need Revit plugin running, a Revit plugin that will extract the information. And here you can also find all the instructions to run this sample. The next sample scenario uses design automation to auto-update models. So in this sample, we use webhooks to get a notification when a new file is uploaded. So that's we setting up the webhook, and we can see that we have a chair without the headrest. And also we have a Revit file using those chairs also without the headrest. As soon as we upload a new version of the chair to our folder, we're going to trigger design automation to extract the geometry from the IPT file. That geometry is extracted as a step file that we can later use to create a new family. So now that we have the geometry from the IPT file, we're going to trigger a second job to open the Revit file and open the family inside that Revit file and update. As soon as that process is done, we are going to send back the new Revit file back to BIM 360. As you can see, now the Revit file is version 1, and as soon as this process is done, it will be updated to version 2. The version 2 of the Revit file contains the newly updated chair with the headrest. So how does it work? We have BIM 360 data management with all the files that are uploaded, and we use webhooks to notify us about the new versions. We trigger design automation 2 times, one with Inventor and one with Revit, to extract the geometry and to update the models. And as soon as we have the model updated, we create a version +1 of that model and send back to data management on BIM 360 docs. In this case, you see that the source of the data is BIM 360, and the destination of the data is also BIM 360. Let's see the sample for this file, for this sample, the code for this sample, sorry. So the code is available here, and it's showing the structure of the sample using webhooks and also using Mongo database to store the access token and refresh token. In this case, as we are accessing BIM 360 data, we need user permission to read that data. That's why we have the MongoDB to store the access token and the refresh token. You can, of course, replace that with a different database system. You can also see that we're using Hangfire as a queuing system because we have 3 main jobs to run, and we have to return OK to Forge when we get the notification. So we receive the notification from Forge, queue that job, and run it later after returning OK to the system. To run a sample like this, you need your Forge account, you need a MongoDB account, and as we're storing temporary information, we're using AWS S3 buckets. You also need Inventor and Revit to compile or change the Inventor and Revit plugins. More information, you can find more information on the source code for the sample. The next sample uses design automation to do a basic design check. In this case, we are using webhooks to notify us when a new version of the file is uploaded. With that new version, we are going to start a design automation job to check if walls and columns are overlapping. Now that we have version 2 and we are uploading the version 3. As soon as this new version is uploaded, we are going to trigger our design automation job to run the .NET code inside Revit Design Automation to extract the information we want. This sample to check over if walls and columns are overlapping is actually one of the samples from the SDK from Revit that was ported and migrated to run with Design Automation. The main change is that we have to remove all the interface and remove the references to the API Revit that is using the interface. We can only use the DB reference. Now that we ran the design check, we are going to create new issues inside BIM 360. And the issue is going to point to a viewer, to a custom viewer, where we can see the problems that we found. With this custom viewer, we have a toolbar that once you click on it, you can see the walls and columns that are clashing. I can go back to BIM 360 issues and resume my process inside BIM 360. So it's a very convenient workflow for the user. So how does it work? We have BIM 360 docs and data management to store the data, and we use webhooks to notify us when the file is uploaded. Once we have this new version, we run design automation with our .NET code with the results that we send to Amazon S3 buckets. We create the issues. The issues are created in BIM 360 issues system, and as you saw before, we have a link to our custom viewer with a better report to show the results of our check. The source code for the sample is also available on GitHub, and like on the other sample, we need a MongoDB database to store the access token and refresh token. Again, we use Hangfire to enqueue the jobs, and as mentioned, we use AWS S3 buckets to store the additional information. For this sample, you need .NET Core, you need Mongo database and AWS account. Also need Revit to compile the plugin if needed. So what's next? If you like those samples and want to learn more, you can try the samples, and if you have any questions, post those questions to forge.help@autodesk.com. The foundation for those samples are actually on the tutorials learnforge.autodesk.io, all the piece that shows how to connect and extract data from BIM 360. The design automation piece is a bit more complex, of course, but it's also part of the tutorial. You can see a basic tutorial on design automation available at this learnforge.autodesk.io. With that, thank you for attending and thank you for watching this presentation. Hope you enjoy connecting design automation with your BIM 360 account. That's very powerful and allows a lot of automation that can save us a lot of time and improve our process. Thank you very much.